All right, welcome back. Today, we are diving headfirst into one of the biggest questions you can possibly imagine, using some truly mind-bending physics to explore the very fabric of existence. So get ready, because we're about to seriously challenge what you think of as real.
So let me ask you something that sounds almost childishly simple, but it's actually one of the deepest puzzles in all of science. Is the world you see really there when you're not looking? We all just assume the moon is still there when we turn around. But what if that most basic assumption is just wrong?
Okay, so before we completely shatter your worldview, we gotta start with the reality we all think we know. Our common sense reality. The one that feels solid, predictable. The one we rely on to, not walk into walls every day.
So this whole worldview, it actually has a name. It's called local realism. And it's built on two ideas that seem, well, completely obvious, right? The first is realism. That just means a ball has a definite position and spin even if nobody's looking at it. Its properties are real, independent of us. And the second is locality. This means if I tap that ball with my finger, it can't instantly make another ball move on the other side of the planet. Cause and effect, It takes time to travel. This is the bedrock of how we think the universe works.
But, of course, there's a but. Early in the 20th century, this brand new, super weird science called quantum mechanics started poking holes in that nice, comfortable picture. And you know who is most bothered by this? None other than Albert Einstein himself.
Yeah, at the very heart of his problem with it was this thing called entanglement. Quantum theory was saying that you could have two particles so deeply connected that measuring one would instantly affect the other, even if they were light years apart. I mean, think about that. Instantly. Einstein just couldn't stomach it. He thought it was ridiculous, and he gave it this famous, dismissive name, spooky action at a distance. And that really set the stage for this massive debate, this huge clash of ideas. On one side, you've got the standard quantum mechanics explanation. These particles, they're basically in a state of maybe until you look at them. And the act of measuring one instantly forces the other one to snap into its correlated state. But on the other side, you had Einstein saying, no way. He argued there's nothing spooky going on. The particles must have some hidden instructions, hidden variables, from the moment they were created. The correlation isn't magic, it was just pre-programmed from the very beginning.
For what, 30, 40 years, this was just an argument for philosophers and physicists to have over coffee. It felt like one of those questions you could never ever actually answer. Who was right, Einstein or quantum theory? It seemed unknowable. But then one physicist came along and figured out a way to actually ask the universe for the answer.
So, in 1964, this physicist, John Bell, has this absolute stroke of genius. He realizes this isn't just about what you believe, it's testable. He comes up with an experiment, a test, that would give you one number if Einstein's hidden instructions were real and a totally different number if the spooky quantum world was correct. Just like that, the philosophical argument was basically over. It was time to go to the lab and get a result.
Okay, look, the math here gets pretty intense. But the takeaway is incredibly simple. Bell proved that if our common sense reality, local realism, is the way things actually work, then there's a hard mathematical limit to how correlated these particles can be. In these tests, the score, let's call it S, could never ever go above 2. That was the line in the sand. If the universe is not spooky, the result has to be 2 or less, period. And then, in the early 80s, a French physicist named Alain Aspect and his team finally did the experiment for real. And the result they got? Well, you can see it for yourself. They didn't just sneak past that limit of 2, they blew it out of the water. The result came in around 2.7, which is almost exactly what quantum mechanics predicted it would be. The experiment had spoken. Our universe is officially weirder and spookier than Einstein ever wanted to believe.
Now, you might be thinking, well, maybe there's a loophole, right? And for decades, that's exactly what physicists thought. So they worked like crazy to close every single one. What if the particles are sending secret messages? Okay, let's separate them by miles and measure them so fast that not even a signal traveling at the speed of light could get between them. What if our detectors are wonky? Okay, let's build near-perfect detectors. And every single time, they got the same result. The conclusion is just unavoidable at this point. Local realism, our basic, intuitive, common-sense picture of the world, is just plain wrong.
Okay, deep breath. So, if our common sense is broken, what do we replace it with? I mean, where do we even go from here? This is where things get really, really weird, and we have to start building a whole new way of looking at the world.
Yeah, This is the central question, isn't it? If a tree falling in the forest doesn't really have a position until something measures it, how is it possible that you and I can both agree that, yep, there's a tree and it's right there? How does a stable world even exist?
All right, let's try an analogy to wrap our heads around this. Picture a red Ferrari. Now imagine you've got one person, observer A, looking at it from the front. Observer B is standing 50 feet away, looking at its side profile. And observer C is up in a window, looking down at its red roof. Now, how do they all know that a single, real red Ferrari is there? The key is this. It's not because the car was this solid thing that existed before they looked. It's because all of their observations are consistent where they overlap. The person seeing the front and the person seeing the side both agree it's red. They can both see the same front corner of the car. The reality of the car emerges from their shared, consistent data.
And this gets us to the absolute heart of this new worldview. What we call objective reality, the solid world out there, maybe it isn't the thing that exists on its own. Maybe objectivity is simply agreement. Reality isn't found, it's formed. It's the consensus that gets built when different observers, different viewpoints, compare notes and find out their information lines up.
Okay, but that leads to a huge final question, right? If reality is all about building a consensus, then why? Why does the universe use these bizarre, spooky, counterintuitive quantum rules to do it? Why does it have to be so weird?
Well, here's the mind-blowing punchline. That spooky action at a distance, the thing that drove Einstein crazy, it's not a bug. It's not a weird flaw in the system. It turns out it's a feature. In fact, it's the most important feature. It's the very tool the universe uses to stitch reality together for all of us.
So to get this, we need one last piece of the puzzle. It's a rule in quantum mechanics called the monogamy of entanglement. It's a fantastic name, and it means exactly what it sounds like. If particle A is using all of its spooky connection to be perfectly entangled with particle B, it has absolutely nothing left to give to a third particle C. Think about it like this. You can't have two equally deep, intimate, soul-bearing conversations at the exact same time. You can only give that maximum connection to one person. Particles are the same. And this rule makes it really, really hard for the universe to keep its story straight across many, many different viewpoints all at once.
And that brings us to the final, absolutely beautiful insight. See, Einstein thought the universe needed this ridiculously complex, hidden instruction book to keep everything straight. But quantum mechanics is so much more clever than that. Those spooky correlations, the very ones that break our common sense speed limit, they are the universe's secret weapon. They act like a kind of cosmic compression algorithm. It's the most efficient way possible for the universe to make sure that my reality and your reality and everyone else's reality can all be woven together into one single consistent story. The spookiness isn't a flaw. It's the very thing that makes reality real.
So I want to leave you with this final thought. If our shared, stable world is built from the consensus between all of us observers, what happens in those extreme places, like at the quantum level, or right at the edge of a black hole, where getting everyone to agree on a single story might be fundamentally impossible? It makes you realize the nature of reality isn't some fixed statement written in a book. It's an ongoing conversation, and we're all a part of it.